Hello and welcome. Today is a recording for Tuesday, March 15th. We are working in Unit 3, Lesson 1. So this is going to be Day 2. And in Monday's class, you identified special segments and lines and circles, including radius, diameter, chord, secant, and tangent. You also were able to explain that two circles with the same radius are congruent. Today we are going to use properties of lines tangent to a circle to solve problems, and tomorrow we will identify common tangent lines, including common internal and common external tangents. So to start off today's class, we are going to take a look at two theorems. Our first theorem is tangent to a circle theorem. And this theorem says that a line is tangent to a circle if and only if the line is perpendicular to the radius drawn at the point of tangency. So the four words if and only if tell us that this is a biconditional. And a biconditional statement is one that is true going in both directions. So we know that we have a tangent line, BC. It is drawn tangent to circle A at the radius. So B is our tangent point. And this is only the case if line BC and AB are perpendicular to each other. That is, they form a 90-degree angle. We also can go backwards in this theorem and say if we know that these two, if this line and segment are perpendicular, then that makes BC a tangent line. So let's practice a problem involving this theorem. Here we want to tell whether segment BC is tangent to the circle. We want to explain our answer and show our work. So if BC is tangent to circle A at the point of tangency drawn to the radius, so this is our radius, this is the line we want to determine if it's tangent, then these segments must form a right angle. And if that's the case, then our Pythagorean theorem should hold true. So remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. And A and B must represent the legs in our triangle. So the sum of those two sides squared have to equal the square of the hypotenuse, this green segment here. So let's plug these numbers in if this holds true. So I can say if a squared plus b squared equals c squared, then segment BC is tangent to circle A. So plugging this in, I can say that BC, which is 12, can go in for A, so 12 squared, plus 9 for AC, that's the second leg, can go in for B, and that has to equal the hypotenuse of 15 squared. So if I simplify this, 12 squared is 144, 9 squared is 81, and 15 squared is 225. So when I simplify this left side, 144 plus 81 does give us 225. So since this equation is true, we can conclude that BC must be tangent to circle A. All right, let's look at another problem. So here we are told that segment CB, this one right here, is tangent to circle A at point B. So B is our tangent point, meaning that these two segments form a 90-degree angle. So we want to use the Pythagorean theorem to find the length from A to C and from D to C. So using our Pythagorean theorem, remember that the legs make up A and B, right? A and B. And our hypotenuse has to be AC. So if we plug this in, A squared plus B squared equals C squared. The yellow sides have to be A and B. And again, that order doesn't matter. So I can say that A squared is AB squared, or 5 squared. B squared is 8 squared. And that has to equal the length from A to C squared. So let's simplify this. 5 squared is 25. 8 squared is 64. Those together must add up to AC squared. So if I add 25 plus 64, that gives me 89 equals AC squared. And to figure out the length of A to C, I just have to take the square root of 89. And when I take the square root of 89, that gives me about 9.43. So I'll use an approximation sign. All right, so if that's this entire length right here, 9.43, that's the length from A to C, I should be able to figure out the length from D to C. And so if you look, D to C is just this part right here. And so I know that AD right here is a radius of the circle just like AB is. So AD must equal 5. So if I'm looking for the length from D to C, then I can just take the entire length of the segment, 9.43, and subtract off the length of the radius. And that's going to give me that DC is equal to 4.43. All right, let's practice another one. So here we are told that line KM is tangent to circle J. We want to find the length from J to M. Well, if KM is tangent to the circle J, drawn at the point of tangency K to the radius, this is our 90-degree angle. So again, we just need to use the Pythagorean theorem. A squared plus B squared is equal to C squared. Now in this diagram, we know that MK and JK form the legs, so those are going to be A and B. And the hypotenuse JM is what we want to find, so that's going to be C. So plugging in these values, I have 4 squared plus 3 squared has to equal JM squared. Well, 4 squared is 16, 3 squared is 9. That's going to equal JM squared. So if I add 16 and 9, that gives me 25. And to find the length from J to M, I just have to take the square root. So JM has to have a length of 5. And our units would be yards. All right, let's try another problem. So MN is tangent to circle K. So MN and the radius form a 90-degree angle. So that means this time our legs are MN and MK, and we need to find MN, and we see that our hypotenuse is KN. So we're going to plug these into the Pythagorean theorem, just like before. A squared plus B squared is equal to C squared. And again, the legs are the yellow segments forming that 90-degree angle. So we can say that A is MN. So we can say MN squared plus MK squared, which is 7 squared, has to equal KN squared, or 25 squared. Simplifying this, 7 squared gives us 49, and 25 squared gives us 625. So we should be able to solve for MN squared by subtracting off 49 from both sides. So that tells us MN squared must be equal to 576, And then, once again, we take the square root of both sides. And that tells us that MN has a length of 24 centimeters. All right, so this next one you should be able to do on your own. So if you want to pause the recording, try it, and then resume to check your answer. So again, if you want to pause, try this on your own, then resume, and you can check and see if you are correct. So here we are told that JK is tangent to circle H. What is the radius of the circle? So if JK is tangent to our circle, that means the radius and JK form a 90-degree angle. And so KJ and JH are the legs, and that makes our hypotenuse K to H. And we want to find the radius length. So we are looking for J to H. So again, we can use our Pythagorean theorem. A squared plus B squared is equal to C squared. A and B are the yellow legs. So A we can say is KJ, so 27 squared, plus JH, which is our radius, squared, has to equal our hypotenuse squared of 45 squared. So 27 squared is equal to 729 plus JH squared is equal to 45 squared, or 2025. So we want to get JH squared by itself. So to do that, we're going to subtract off 729. And that tells us that JH squared is equal to 1,296. So to find just JH, which is again our radius that we're looking for, we need to take the square root of 1,296. And that tells us that JH is equal to 36 centimeters. All right, we've got 2 more questions to get through, and then in the next recording, we'll take a look at our second theorem. So here we have WX and its tangent to circle V. We want to find the measure of angle Y. Well, if WX is tangent to the circle, then these 2 segments form our 90-degree angle. And we should be able to use the triangle sum theorem to figure out this angle down here. We know that all 3 angles of a triangle add up to 180. And this angle W represents a right angle, so that's 90 degrees. So I can take 180 and I can subtract off 90 and this angle 36, and that's going to equal the measure of angle Y. So if I subtract 90 and 36 from 180, that tells me that angle Y measures 54 degrees. So we can also use this theorem to calculate angle measures. Now we're going to do one more problem. So here we have ST and TU are both tangent to circle Q. So here's ST and here's TU. If they are both tangent to each of the radii, then these 2 angles are 90 degrees. 90 here and 90 here. So now we have a quadrilateral this time, right? And all 4 angles of a quadrilateral add up to 360 degrees. So if I take 360 and I subtract off both 90-degree angles and the angle that measures 33, that's going to equal the last angle, or the measure of angle Q. So if I take 360 minus 90 minus 90 minus 33, that tells me that the measure of angle Q is equal to 147 degrees. So that wraps up part 1 of today's recording. So once you are done, you will then be able to watch the second part of today's class.